In this video, I will talk about relations, and remember that from the past few videos we discuss sets, and in sets we also talk about relations as well, relations and functions and everything. So this is a concept used in topology, mostly in topology. So the topic of this video is relations, and in the next video I will talk about functions. If we have two sets, suppose we have two sets A and B, if we have two sets, then the relation, for example, we call that as relation R from A to B, is a subset, of A cross B. And you remember that this was Cartesian product, which we already defined. If we could not define Cartesian product earlier, then we cannot write this as a subset. Or how can we write the A cross B? It will not be clear. So so it will be an ordered pair. Given given an ordered pair, given an ordered pair x, y in A cross B, x is related to y by relation R. That is the definition of relation. So in symbolically we can write this as x, we can write this as x R y. So it is a kind of ordered pair, but it is a subset of that Cartesian product. So x R y means x y belong to that relation. If we write x does not in a relation, then we write x y is not in a relation, then we have x y does not belong to R. So that's how we define the relation. Let me just give you some example on that. Example, suppose we have A is equal to 1, 2 and B is equal to 1, 2, 3, and we want to write this as some relation xy belong to A cross B. So xy is coming from Cartesian product, but xy will be relation. A cross B is the bigger set, and R is the smaller set, or it is a subset. It can be equal to A cross B, but it is a subset. And it must satisfies xy belong to R, which satisfies, so it means that it will be a part of relation only when we have x minus y by 2 is an integer. So this is the question that has been asked over here. Solution. Now, if we see the Cartesian product of A cross B, first we need to find the Cartesian product. A cross B, that will be equal to 1, 1, 1 2, 1 3, 2 1, 2 2, and 2 3, 2 3, 2 3. These are all A cross B Cartesian product. This is a bigger set. Now, what belongs to R? The relation. If it satisfies this property, suppose I want to check whether 1 1 is in a relation. So 1 1 belong to R. So first we need to check 1 minus 1 by 2, which is equal to 0. And 0 is an integer. So it means that 1 1 belong to relation R. So if you want to write the number of elements, these are in relation, we can write this as 1 1. This is first element. Now I want to check 1 2 either belong to R. This is just a question mark. So 1 minus 2 divided by 2, and we get minus 1 by 2. So it is not an integer, so it does not belong to relation R. So we cannot write this in a relation set. Similarly, 1 3, so we are checking this 1 3. 1 3, 1 minus 3 divided by 2 minus 2 divided by 2 minus 1, so it belongs to relation R. So we have 1 3 in the set, 1 3 in the set, so on. Similarly, we can also check 2 1, for example 2 1, 2 minus 1 by 2 minus 1 plus 1 by 2. So we have 1 by 2, which is not an integer. 2 1 does not belong to R. 2 2, 2 minus 2 is 0. It does belong to R. 2 2 belong to R. 2 minus 3, which is minus 1 by 2. So it will not belong to R. So we have, you can see that A cross B is the bigger set and R is the smaller set. So R is the relation and A cross B is the Cartesian product over here. Okay, let me just give you another example on relation. Example, we define some relation x, y belong to C, and this relation is coming from R cross R. X, y belong to R cross R, R cross R. So R cross R is the bigger set. It is a Cartesian product. And there is a relation xy belong to C means that x square plus y square is equal to 1. Now the question has been asked is 1 0, 1 0 belong to C. This is first question. Then the next question is 0 0 belong to C. This is C is the relation, remember that. R cross R is the Cartesian product. So 1 0 to be true for it belong to C, we put this in the given constraint, which is 1 square plus 0 square, that is equal to 1, which is equal to 1. So 1 0 belong to C. So if we want to generate a set for C, so we can say that 1 0 is in C. What about 0? 0 square plus 0 square, it is equal to 0, which is not equal to 1 on the right hand side. So 0 0 does not belong to set C, relation C. What about minus 1 by 2 and under root 3 by 2? What about this set? So we put that value into the constraint minus 1 by 2 square plus and under root 3 by 2 whole square, that will be equal to 1 by 4 plus 3 by 4, and that is equal to 1, which is equal to 1 on the right hand side. So we can say that this is also a part of relation C. So on. There can be some other relation as well. Okay, so this was about the relations for circle. This is a kind of this is a circle, and in the previous example we saw some constraint for A cross B and its relation x y that belong to R, which should satisfy this constraint. So this was all about the relations. Thank you for watching.